Hey guys, great to be back with y'all again today. We're going to be talking about problem solving today. And we're going to be talking about a wide variety of skills, really. We're going to be talking about 3.4 A and K and 3.5 A and B. And that's problem solving with all operations, basically what it is. And the I can statements is I can choose the correct operation to solve a word problem, and I can use the correct strategies to solve to problem solve. So we're going to look at some of the vocabulary. Since we're using all operations, that would be addition, subtraction, multiplication, and division. Those are the four operations we use in math. And we have for addition, we have add in are the two numbers we put together to get our sum, which is our answer. And minuend and subtrahend and difference. Difference is the answer to a subtraction problem. There's a community property of addition. That means I can switch the numbers around and still get the same sum. That's not a fact with subtraction, though. There's specific order. We always start with a larger number in third grade and take away a smaller number from that to get a whole number or a positive number. Multiplication vocabulary. You know, it's factor, those two numbers we put together in our multiplication to get our product. And there's a community property of multiplication, which means we can switch numbers around. 5 times 4 is also 20. And division vocabulary, dividend, divisor, quotient. Quotient's the answer to a division problem. And we cannot switch around. I cannot say that 5 divided by 40 equals 8. That would not be a true statement. So there's a specific order way we divide things, just like subtraction. They're very similar. Have a few videos we're going to watch about these skills. We'll watch one of Aaron's videos talking about how to solve problems using different operations and stuff. So let's go ahead and get ready for those videos.
Hello, and welcome to 5-Minute Math. Today we are looking at the third grade concept of representing addition and subtraction problems. This is standard 3.5A in the great state of Texas. And we're using item number 30 off the 2018 released STAAR test. If you have not done so already, please go ahead and take a moment to pause the video, see if you can work this problem out on your own, and then unpause it. We will look at our answers together. So this looks like a fairly complex problem. If you look at the answer selections, F, G, H, and J, they don't have regular equations, but they do have these strip diagrams. So let's just go ahead and label these. You might have heard them before as part-part wholes, and that's fine. Part-part whole is a type of a strip diagram. There are other types of strip diagrams that are not necessarily part-part wholes, so either word works here. So we need to have a picture, a representation of our problem situation up here. So let's see if we can figure this one out. I'll write an equation first, and then we're going to match that to the correct strip diagram. There are a total of 294 restaurants. So when they give you this total right here, I'm just going to go ahead and put A equals 294. Because when they use this word total, that lets you know that that's going to be on one side of the equation. Remember, the equation needs to balance out. We need to pretend like our equation is like a balance, right? And so whatever's on this side, put a little box here, needs to equal everything that's over on this side, even if it looks a little bit bigger, because we're going to have some addition, subtraction, multiplication, division. But we need to balance it out. So of these restaurants, we've got 196 on the highway, 49 downtown, and then the rest. So there's my unknown. So I've got 294 restaurants, and it seems like we're just going to put 196. I can put that kind of in a box here. We're going to put 49 in a box here. And then the rest. So the rest is going to be my unknown. So I'm just going to put a little question mark here. So if I wanted to balance these two out, 196, it looks like we're going to have some addition signs here. So I can write this as a number sentence, 196 along the highway, plus 49 downtown, plus my question mark. Those are the ones on the shopping mall. All of that equals 294. So that's an equation to represent this problem. If we're wanting to find the number of restaurants in the city that are shopping malls, we can start with this and we can use some different equations that use inverse operations, fact families. But we are looking at strip diagrams. So in a strip diagram, this is the number one thing we need to remember. When we're looking at a strip diagram, the whole or the total, if you ever get a whole or total, if that's given to you and one of the unknowns is actually a part, the whole always goes up on top. That's how we do a strip diagram. So we're going to put this right here. So that represents everything. And then underneath it, we already know we've got 3 chunks. Sometimes they try to make them proportional. Sometimes they don't. I'm not going to worry about it this time. I'm just going to say 196, 49, and then question mark. So when I draw it like this, I don't have to include the plus signs because the strip diagram shows you that when you connect these connecting bars are automatically plus signs. And so when you're looking at that, you see there's only one answer selection that actually has the whole total up on top, 294. And so they did make it proportional. They made that 196 much larger than the 49, which makes sense. So our answer is going to be G. Now, why is our answer G and not F, H, or J? Let's take a look at those. Look at what F, H, and J do. First off, F, H, and J all put your total down as one of the parts. They put the whole down with one of the parts. And if you add 294, 196, and 49 in F, or 294, 49, or 294, 196, take a look at these two. 294 and 196, they're way bigger than 49. That doesn't make any sense. 294 plus 49, already larger than 196. That doesn't make any sense. And then all of these 3, we don't know what they're going to add up to, but it's going to be much larger than 294. And we already know that 294 is our total. So our answer is G.
Okay, well, we're going to look at this problem together right here. It says the Lucio family will be driving a total of 974 miles from their house to the beach for their summer vacation. They drove 327 miles on the first day and 401 miles on the second day. How many more miles do they need to drive to reach the beach? So I like to use cube strategy. It kind of helps us understand what the problem's asking. So that's C-U-B-E-S. And first thing I'm going to do is I'm going to circle the important information. I have 974 miles. I have 327 miles. And then I have 401 miles. Next thing, I'm going to underline the question, make sure I understand what they're asking me to do. And I would say, how many more miles do they need to drive to reach the beach? The next is the B, and that's box in some operational clues. And just like we talked about before, how many more? How many more right there? And that's kind of a key word for subtraction. And that really looks like most of the, most of the phrases or words that's going to help me understand an operation. Next thing I'm going to do is I'm going to evaluate. Okay, when I evaluate, I like to look at my labels, and I've got 974 miles right there is the total distance. 327 miles on the first day and 401 miles on the second day. And in my answer for my label, the label for my answer is going to be miles. So it sounds like it's there's going to be addition, subtraction involved there. And we already talked about, right there says how many more, looks like subtraction problem. But, typically, we don't subtract 3 numbers at a time. So we're going to go ahead and do a strip diagram. I like to do strip diagrams. Okay, I'm going to do something like this. And right here I see total. It says, I guess that's another keyword. Okay, total. So when I'm doing a strip diagram and I know what the total is, that's going to go up top. That means my answer is not going to be larger than 974. And I can also use that, if I'm looking at answer choices, see if an answer is reasonable. So if my answer is larger than 974, it's not, that's not a reasonable answer. Okay, and it looks like it says drove 327 on the first day, 400 miles on the second day, and how many more miles do they still need to drive? So we're going to say it probably took them at least 3 days to make it to the beach. So I'm going to separate it into 3 sections right there. We'll say the first day was 327 right here. The second day was 401, and we need to figure out how many more is left. So it's going to look, the strip diagram will look sort of like that. So make my 0 a little bit better there, so I don't get confused after 6. So it looks like there's a lot of different ways to do this, a problem like this. When I'm trying to find out this section right here, I could subtract 327 from 974 and then subtract 401 from the difference of that. Or typically what we like to do is we like to add these two together right here, 327 and 401 together, and then we subtract the sum of those two numbers from the total distance it takes to go to the beach. So I'm going to do something here really quick that don't see a whole lot. I definitely don't see students do this a whole lot. Is I'm going to estimate what my answer is going to be. I'm kind of getting to the solving portion right now, so I'm going to check my solve right there. So I'm going to make an estimate of what my answer should be before I do any of the adding or subtracting, because this is a two-step problems. So chances are, coming back from Christmas break, maybe be a little bit lazy or forget some steps. So it might be helpful to go ahead and do some estimating to what our answer is going to be. Okay, so what I can do right here is I can look at 327 and 401, and I like 327 is really close to 325, and 25s kind of make me think about money, quarters and stuff. So I can say 325 plus 400 would be about 725, pretty close to it, 725. And then I could subtract 725 from 974, or I could just go up 975, so that'd be like 3/4 and 1/4. So I could do that subtraction problem really easy. That means if I took a quarter away from 75 cents, that would leave 50. And then I take 700 from 900, that's 2. So my answer is going to be about 250, close to 250. Okay, so we'll go ahead and do the math and see if that works out. See if we get somewhere close to 250. If we get somewhere close to 250, a pretty good chance that we did all our steps correctly. And like I said, we'll do it both ways. The first way we'll do it is we'll go ahead and take 974 and subtract 327. So right here, I'm in the ones place. I got more on the floor, so I cannot take 7 away from 4. It's not possible. So I'm going to have to go to the tens place. I'm going to take one of my tens. That's going to leave 6 tens. And that will, if I move 10 to the ones place, that'll give me 14 ones. And I know 7 from 14 is 7, because 7 plus 7 is 14. And then 2 from 6 is 4. And then 3 from 9, could say it's 3. 4, 5, 6, 7, 8, 9 is 6. So after the first day of driving, they still have 647 miles to go. So we'll go ahead and subtract the amount that they drove the second day, which is 401. So 1 from 7 is 6. 0 from 4 is 4. And 4 from 6 is 2. So I got 246, and that's really close to 250. Okay, but we'll go ahead. So I probably did all my steps correctly, but we're going to go ahead and do it the second way too. We're going to add 327 plus 401. That'll be the total they drove the first and second day. So 1 plus 7 is 8, 0 plus 2 is 2, and 3 plus 4 is 7. So 728 miles is how much they drove the first 2 days, which is kind of really close to what my estimate was there, 725. And then if I go ahead and subtract, let's scoot over a little bit here. Subtract, go 974 minus 728 is which how far they drove the first 2 days. I'm in the ones place right here, and I have 8 on the bottom, more on the floor. So that means I need to go next door. I'm going to take one of my 10s. That's going to leave 6 10s. That give me 14 ones. And then 8 from 14 is 8, 9, 10, 11, 12, 13, 14. That's 6. Okay, and then 2 from 6 is 4. And then 7 from 9 is 7. 8, 9 is 2. So I got 246. And you see both of these matched, both ways I did it. We kind of talked about the properties of addition and subtraction right there, where we subtracted twice, or we added and then subtracted. And typically this is probably the way I see most third graders do it. And I like that because typically we're better at adding than we are subtracting. So instead of having to subtract twice, which is maybe a little bit more difficult skill than adding and then or subtracting, or adding then subtracting. So that's typically how I see third graders do it and how I'd recommend them to do this problem. But so that means they still have, that's 246 miles left to drive to make it to the beach. Okay, let's look at this problem together. It says the Chamber of Commerce is hosting a craft show on Saturday and Sunday. Christine and Faith made 865 beaded earrings to sell at the craft show. They sold 250 earrings on Saturday and 115 earrings on Sunday. How many earrings did Christine and Faith have left after the craft show? So, I like to use my cube strategy. So that's C-U-B-E-S. And first thing I'll do is circle the important information. So I have 865 beaded earrings. 215 or 250 earrings. That was on Saturday, and 115 earrings on Sunday. Next step. That looks like all the important information. Next thing I'll do is underline what it's asking, and that is how many earrings did Christine and Faith have left after the craft show? So I'll box in some operational clues. And I think I would box in have left right here. That's what I'm trying to figure out, how many they have left. And probably put a little T right here because this is the total amount of earrings there are. That's important and help me solve it. So I'm going to start evaluating. I'm going to evaluate, and so everything we're talking about is earrings. So we have a total number of earrings. We had earrings they sold on Saturday and earrings they sold on Sunday, and we're trying to figure out how many earrings she has left. So all my labels are the same. So typically on things like that, if we're not talking about any equal size groups, it's probably going to be an addition subtraction problem to solve it. And this looks very similar to the other problem we did just a minute ago. And it looks like we have some they sold on Saturday, some they sold on Sunday. Try to figure out how many they have left. So I'm kind of lay this problem out right here. So we have a total of 865 earrings. And then we're going to take away what they sold on Saturday and Sunday. So on Saturday they sold 250 plus the amount they sold on Sunday, which is 115. And that'll tell us how many they have left. So I can kind of break this apart. this is kind of, I'm going to write this down. This is kind of what I'm thinking on this problem. I'm looking at, so I'm going to take 250 and 115 away from 865. I can group some things together right here. I see 50 and 15. I know 50 and 15 is 65. So I could take 65 away from 865 real easy. That would be 800. And that would still leave 200 and 100. And I can group 200 and 100 together really easy. That is 300. And it's easy to take 300 away from 800. That would be 500 left. So that means they have 500 earrings left. And that's pretty easy. We kind of did that in our head. That's a problem you could probably do in your head. Okay, but still, you know, whenever we're doing stuff like this and we're doing a problem, and a lot of times they have us fill out gridables and stuff. So if we're off just a little bit, that means the whole problem's wrong. So let's go ahead and just do all the steps. Like I said, we can do it two different ways. We could do 865, take away 250, and then take the difference of that and subtract 115. We'll do that first. So that's 865. And you see when I use my grids like that, I put all my digits in a grid, and I'm going to minus 250. And that's a pretty easy subtraction problem. 0 from 5 is 5. And then 5 from 6 is 1. And 2 from 8 is 6. So now I could subtract, scoot it over a little bit. I could subtract 115 from that. That's 115. I subtract that. 5 from 5 is 0. 1 from 1 is 0. And then 1 from 6 is 5. And that gave us 500, exactly what we came up right here. Okay, the next thing I'd like to do is go ahead and add 215 and 250 together and subtract that from the total. So that would be 250, 115. 5 plus 0 is 5. 1 plus 5 is 6. And then 2 plus 1 is 3. So 365 that they sold on Saturday and Sunday. And to subtract that from the total that they made, which was 865. So 365. So 5 from 5 is 0. 6 from 6 is 0. And then 3 from 8 is 5. And that is 500. So I showed you two different ways to solve it, actually three different ways to solve this problem. We went ahead and kind of used mental math right there to solve it. We subtracted twice, and then over here we added and then subtracted. And that's probably typically the way that most third graders should do this problem, because like we said in the problem before, adding is easier than subtracting. So instead of subtracting twice like we did here, if you add once and then you only have to subtract once, and typically you're going to get better results when we do operations that we do better. So let's go ahead. Okay, let's go ahead and look at this next problem together. It says, this chart shows the new books Mrs. Cortez ordered for the school library. And you can see there's a little table right there talking about new books ordered. She ordered fiction and nonfiction. So in the fall, she ordered 114 fiction and 109 nonfiction. In the spring, she ordered 142 fiction and 127 nonfiction. So what we're trying to find out is, how many more books did Mrs. Cortez order in the spring than in the fall? So I'm going to organize my problem here a little bit using my cubes. So I'm going to circle the important information. And this table right here has all the important information in there. I'm going to underline the question, and that is, how many more books did Mrs. Cortez order in the spring than in the fall? I'm going to box in my operational clues right there. I see how many more. Okay, and that's going to the evaluation stage. Whenever I see the word how many more, typically I'm going to have to do some subtracting there. Okay, but we'll go ahead and go into the solving part of this. the first thing we need to do to solve this is I would go ahead and figure out how many books did she order in the fall. Okay, yeah, I can use my use some mental math here, some of my properties of addition here. So 109 is really close to 110, so I'm going to put this 110 right there. And then if I took 1 from my 114, that'd make it 113. So basically I took 1 from the fiction and added it to the nonfiction to make it a little bit easier math problem to solve. And I can that'd be easy to solve because 113 plus 110 would be 223. So she ordered 223 books in the fall. So how many books did she order in the spring? Okay, yep, that's pretty good. I can just look at my place value because I'm looking at my place value. It doesn't look like I have to do any regrouping there. So I'm going to add the ones place up first. 7 plus 2 is 9. And then 2 or 20 plus 40 is 60. And then 100 plus 100 is 200. So it looks like she ordered 267 books in the spring. So how many more books did she order in the spring than in the fall? That sounds like a subtraction problem. So how many more books did she order in the spring than fall? Yep, we'll go ahead and we do a subtraction problem. So in the spring, she ordered 269 books. In the fall, she ordered 223. So you had to reorder that there because we always put the big number on top when we subtract. 3 from 9. 3, 4, 5, 6, 7, 8, 9. That's 6. And then 2 from 6 is 4. And then 2 from 2 is 0. So that means she ordered 46 more books in the spring than she ordered in the fall. Okay. Another important thing is when we're doing gridables, we see gridables a lot. And I see third graders mess up on them all the time. So 46, don't check that, 46 was my answer. So to do that, I would put the 4 in the tens place, which is right here, and the 6 in the ones place. And then I would bubble in the 4 directly below it. When I bubble it in, I want to make sure I take my time. Make sure I don't see any white left in there. I want to stay inside my line right there. And then 6, same thing on that. We're going to take our time and bubble it in dark and neat, where you don't see any, where you don't see the number at all, you don't see any white in there. That way when they bubble it for us, it gets the right answer for us. So that means she got 46 more books. Okay, it's time to do your independent practice again. Once you complete your assignment in Schoology, I'll go ahead and put a PDF in there. So if you like to print these worksheets out and do them pencil and paper, and that's what I'd recommend you doing. Practice, writing them down on, working the problems out and using your cube strategy and all that. And but make sure you go ahead and put it into the blue puzzle piece with today's date on there. And take your time, do your very best. If you have any questions, please email your teacher or send them a message on Schoology. And best of luck to you.